Hello everyone. Today we are going to solve the LeetCode question. The number is 2429 and the question name is minimizing XOR. So in this question what we have to do, we are given two positive integers num1 and num2. Find the positive integer x such that x has the same number of set bits as num2 and the value x XOR num1 is minimal. Note that XOR is the bitwise XOR operation. Return the integer x. The test cases are generated such that x is uniquely determined. The number of set bits of an integer is the number of ones in its binary representation. So what we have to do in this question, we are given two numbers num1 and num2, and we have to figure out an positive integer x which is having a same number of set bits. What are set bits? If we represent a number into its binary representation, for example, so let's suppose I will represent 5 in its binary representation, it will be 101. So here 1 is called as set bit and 0 is called as off bit. So offset या off bit कहते हैं maximum time. So what we have to do, we have to find an x which have the same number of set bits as num2 and the value of x XOR num1 is minimal. And what we will do, we will take the bitwise XOR of num1 and x. It should be minimal. Uh, Let me tell you what is XOR operation. If we do 1 XOR 1, it comes to be 0, and 0 XOR 0 is equal to 1, and 1 XOR 0 equal to 1. Sorry. Okay. So 1 XOR 0 or 0 XOR 1 is almost equal. Let me write it. 1 XOR 1 equals to 1. Okay. So uh, how can we approach? Let's discuss the example first. Here in this example, num1 equals to 3 and num2 equals to 5. So let me represent in its binary form. We will write by 5 as 101 and we will write 3 as 11. So num2 is 5, which is 101. Here number of set bits are 2. As you can see, there are one set bit and one set bit, and there are two set bits. Okay, so there are also set bits equals to 2. But so the x value is 3. The x value is 3. X equals to 3, which is 1 1 in its binary representation, and here set bits are also 2. So let's see, the x is fulfilling the condition. X has the same number of set bits as num2. Num2 has 2 set bits, as we can see, and x also have 2 set bits, as the question is saying. The XOR value of x XOR num1 is 3 XOR 3, which is equals to 0. Uh, okay, 3 XOR 3 is 0. Let me write the XOR operation also. Let's suppose this is n1 or this is x. So the result will be equal to 0 0. Okay. So how can we approach this question? We can, one of the solution is that we will firstly found out the num2 firstly represent find the number of set bits in num2, and what we can do, we can make combinations from it, like if the num2 contains two number of set bits. So how many combination can be processed? uh, an integer consists of 31 bits, so there are 31 C2 operations which can be exist. Okay, but there is a slightest twist that we cannot figure out what how many combinations it can be made. Like what if uh, 31 C2 is a little bit number, but we cannot figure out 30 if we want to find out 31C5, like let me figure out what is 31C5. Let me see 31C5 for you guys. Okay, combination. As you can see that 31 C5 is a little bit very big number, 1,69,000, which is approximately 10 to the power 5. And if we try to figure out some more combinations like 31C, 10 or 31C, it will cross to 2 to the power 31. Okay, it will not cross 2 to the power 31, but it will cross 10 to the power 8 or 9, which is not acceptable. It will give you TLE. So we cannot find out the all combination, and it is also very much difficult to find all the combination. We can figure out, but it is difficult. So what can be the better approach? The better approach can be, what we can do, we can use some XOR property. There I have tell you the XOR operation previously. Like we can use these properties. What are these properties saying? 1 XOR 1 equals to 0, 0 XOR 0 equals to, sorry, this is 0, sorry, and 1 XOR 0 or 0 XOR 1 equals to 1. So what we can do, we can use the first property. How can we use it? Let's suppose I want to let's take an example where n1 equals to 15 and n2 is equals to I will take any example. Let's suppose that 19. So n1, if I represent n1 in its binary form, how can I represent 1 1 1 1, which is 1 plus 2 plus 4 plus 8, which is 15. And if I want to represent 16, 1 which is representing 16, 0 which is 8, फिर 0 which is 4, then 1 1, 1 plus 2 3, 3 plus 16 19. Okay, so if I want to figure out the x, so I will take the I will use the XOR property. So what can be the XOR property? XOR property says if 1 1 then 0 and 0 0 then 0, if 0 1 then 1. Okay, so if I will put x, let's x consist of 5 bits. Okay, let's consist of 5 bits. What can be the first bit? Let's suppose it has 4 bits. Okay, it has 4 set bits. So x also must contains 4 set bits. So what can be the first bit if it is fifth? What if it was the fifth bit? What should be the fifth bit of x from the right side? So as we can see that both contains of 1 1. Sorry, we just have to, sorry, we oh, I totally forget it. The x must contains the same number of set bit as num2. So n2 consists of 3 set bits. so x must also contains of 3 set bits. So how can we figure out? As you can see that num1 contains of 4 set bits. Okay, so we will go from the left side, go from the left to right, and we will try to make them 0. Okay, how they will become 0? If I will put 1 as the first bit, which will be let make me a 5-bit number. Okay, so if it is 0, then there is no requirement of any set bit. Okay, if it is 1, then there is a requirement of 1 to make it 0. Okay, so we will use the set bits only when we required to make a 1 0 from the left side. And why we are going from the left side, why we will not go from the right side? Because the left side bits contain the most weight. It means if we will represent 2 की power, we will represent uh, the binary representation as 2 की power 4, then 2 की power 3, 2 की power 2 की power 2, 2 की power 1 and 2 की power 0. This is the decimal value that this binary bit is representing. So if we will close this bit, it means if I anyhow make it off. Okay, so I will decrease the more value, more intensity. Okay, then this bit. That's why we will off this bit first, and then we will find if we have any many if we have any more such bits left, set bits, then we will off these bits. Okay, so here as we can see that we can ignore 0 because there is no requirement of 0 because it is already a offset bit. So why there is a requirement to make it a offset bit? So we will ignore it. We will use only set bits where n1 consists of set bits. Okay, so as you can see that this fourth position consists of one set bit, and as I already use one set bit, so there are two remaining set bits left because n2 also consists of three set bits, and the condition is that x must contains the same number of set bits as num2. So n2 consists of only 3 set bits, that's why we can only use 3 set bits. So if and the next bit is also a set bit in n1, so we again use 1 again, and the third set bit also consists of 1, so we will again use it set bit, and the answer becomes 0 1 1 0. Okay, I will take one another example. It was the example as you can see here. N1 equals to 1, which can be represented as 1 in binary both, and N2 consists of 12 which can be represented as 1100. Okay, so which consists of 2 set bits. Okay, so how we have to figure out the x value? So x must also contains of 2 set bits as per the condition of the XOR, as per the condition of the question. Here is the condition: x has the same bit of x has the same number of set bits as num2. So if I only have there is we cannot use only one set bit. Okay, we have to use 2 bits. Okay, so let's suppose ki if it is 0 1, this will be represented as 0. We can join 0 as much as we want in the left side, but we cannot use it at the right side. It will change the value. If we join the zeros on the left side, it does not affect the value of the binary representation. Okay, it is same as we will join 0 before 1 0 or if I join 0 after 1 0, this becomes 100 and this is same as 10. Okay, so we cannot do this operation, we can do this operation. Okay, so the x value is, as we can see here, is the 0th bit, so we doesn't need to use this set bit. And here we can see that it is one set bit, so there is a need of one set bit. Okay, so we will use it at there, and we will put the the second bit as 0, but the condition was not fulfilled. The condition is x has the same number of set bits. So what we will do, the x XOR num1 is minimal. Okay, this is the question. So if I will, let's suppose if there are consist of as many, as I say, I can put as many as zeros I want. What if I make it any one of the set bit as 0 1? Why I have to do this? I have to it is the must condition, that is same number of set bits as num2 consist, it also x must consist. Okay, so I can make any of the set bit as 1. Okay, but the second condition saying that as XOR num1 is minimal, so I have to put 1 as optimal, so that the XOR operation will give the minimal. So if I put at randomly, it will not, it can give there is a possibility it can give the minimal value, but I have to put it optimally, so that it will give. If I put 1 here, it will not give the minimal value, but if I will put 1 here, it will give an better optimal value which is minimal, but it is also not this. So what we will do, we will iterate from right to left, means from the right side to the left side. Okay, right to left. Okay, we will move from right to left, and we will we will choose the off bits, and we will make it a set bit, the remaining from the remaining set bits. Okay, so this is the answer which is given also here, x equals to 3, which is the minimal. Okay, so let's do the let me write the code of it. Okay, wait a second. Okay, I have written the code, let's execute. Okay, working fine, and let's submit it. Yeah, it is working fine. So how I will write the code, let's see. I have taken a count variable which count the number of set bits from num2. uh, I am using bit masking, sorry, yes, bit manipulation for getting the number of set bits. You can use another method also. Okay, like dividing by 2 or nothing, or other things. I have taken an variable I and set it as 31 with the leftmost bit in an integer. Okay, and I will take an answer. Answer is representing nothing but x. Okay, it is answer is equals to, answer is representing x. So what I will do, while I not equal to minus 1, what is saying, I is not at the last most position. Love, it means like x is equals to 101, so I is not there in the right side of the one last one, rightmost one, or rightmost bit, we can say. It will iterate, or it was, and cnt not equal to 0, cnt is count. Okay, count is not equal to 0, like we can only set those bits if we have the count, okay, we cannot set the bits uh, greater than the number of set bits available in num2. Okay, so I equals to 31, int answer equals to 0. Okay, what we will do, we will initialize answer as 0, while I not equals to -1, I have already tell, and cnt not equals to 0. It means we have remaining set bits. Then we will, what we will do, we will check. This is just nothing but the representing the ith bit of the num1. If the ith bit of the num1 is equal to 1, what we will do, we will makes answers that bit also equal to 1. Okay, and minus it from cnt means count. It means we have used a one set bit, and the remaining set bit is count cnt, and we will check further for other right bits. Okay, and at the end, like, I will initialize I with 0, and we have remaining some set bits, as I have told in the second example, that we only required only one bit for making it 0, but we, as per the condition, we have to use the second bit also. So what we will do, we will iterate from the rightmost to the leftmost, and the off and we will make offset bit as 1. Means we will make offset bit as set bit, and if cnt is greater than 0, cnt is greater, count means the if there are some number of remaining set bits, so we will iterate it from there, and we will make all the offset, means we will make the number of offset bits equals to 1 where cnt is greater than 0, and at the end we will return the answer. This is the code, as you can take the screenshot also. I will make it a little bit, you can stop the video and you will take the screenshot and try to write it from yourself. Okay, and I have already submitted. Let me submit it again. The net is little bit slow, but I have already submitted the solution. It will get accepted. Okay, thank you for watching.